Hey GED students, it's GED question of the day time, and for the second day in a row we've been asked, are the fractions below equivalent? So if you haven't seen it yet, I suggest you go check out the video from right before this, the first question of the day about equivalent fractions, because we're going to build on that knowledge today. So are the fractions below equivalent? Like we talked about last video, there are a couple of different ways. I certainly don't think these are the only ways. Oh my land. Good math always works. There's lots of logical things you could do here. But two common ways to tackle this problem. One, if you remember the fact that equivalent fractions have equivalent cross products, you could very quickly solve this like a mathematician, or I shouldn't say solve it, prove that these are equivalent or not equivalent like a mathematician. So equivalent cross products. What does cross products mean? Well, product means the answer when you multiply. And cross, what do I mean by that? I mean, we're going to kind of go in a cross pattern from numerator to denominator, from numerator to denominator. So equivalent fractions have equivalent cross products. They're in proportion. So what's going to happen here is I could multiply the numerator of one fraction by the denominator of the other. 18 times 15. If I were to do that, I think it's 270, but I'm telling you, it's I'm having it is 270. Look at that. My TI-30XS verified my brilliance. Okay, and then I'm going to do the other cross product. Cross product, again, is taking the numerator of one fraction, multiplying it by the denominator of the other. So 12 times 24. Let's give that a try. If I do 12 times 24, I get 288. So remember what I said. I said equivalent fractions have equivalent cross products. Examine these two cross products we just found. One of the cross products was 270. One was 288. Are they equivalent? Are they equal? Well, no, of course not. 270 isn't equal to 288. And so what my guess, or I shouldn't say my guess, my proof here is no. But the thing about this rule, which is a mathematician's favorite, we love it because we don't struggle to remember it, is that GED students often struggle to remember this little statement of fact. Equivalent fractions have equivalent cross products. If you can't remember this, you'll never remember how to do the problem this way. So I have more advice for you. And that advice for you is, if fractions are equivalent, oh my gosh, we already know that they have the same relationship between the numerator and the denominator, which means they will reduce down to that basic relationship. And you could just reduce the fraction. So if you are not feeling super like your memory is failing you and you're not sure what to do, at least try reducing a couple of fractions. If they are equivalent, they will reduce to be the exact same thing. So let's check it out. Let's look at 18 over 24. Now I happen to know that 18 and 24 are both on my 6 times tables. The bigger of a number common factor that you can divide out, the faster this reducing is going to go. So 6 is a nice and large, bigger than 2, bigger than 3. So I'd rather take it out if I see it. So 18 divided by 6 is 3. And you might be saying, Kate, what if I don't know my 6 times tables? That's fine. You could take out one factor at a time until you get all the way reduced. And 24 divided by 6 is 4. And I see that I reduced down here to 3/4, or 3 out of 4. My basic relationship that this fraction is made of is out of every 3 there are 4. Or let me rephrase that because that didn't come out right. But for every 3 in the numerator, there are 4 in the denominator. There we go. I was clearer with my language there. So that's the basic relationship of the fraction 18 to 24. Now let's look at the fraction 12 to 15, or 12 out of 15 is another way to think of it. They too have a common factor. The numbers 12 and 15 are both divisible by 3. They're both on the 3 times tables. So I think every single video I have some kind of technical difficulty, just so you guys can see I'm a techno moron. At least I'm pretty decent at math, huh? Okay, so 12 and 15 have a common factor of 3. Again, when you reduce, you just divide out common factors so you can get down to the most basic relationship contained within that fraction. So 12 divided by 3 is 4. 15 divided by 3 is 5. Now I know I'm done reducing that fraction because the only thing 4 and 5 have in common, the only thing they're both divisible by, is the factor 1. And as I always say, 1 and done. When the only thing the numerator and the denominator have in common is a factor of 1, you're done reducing. Okay, so if you look at this, I did not get back down to the same relationship. For this fraction, I have 3 in my numerator for every 4 in my denominator, whereas here I have 4 in my numerator for every 5 in my denominator. When they reduced, they did not come out to the same number. 3/4 is not the same as 4/5. Therefore, these two fractions are not equivalent. No. So there you go, 2 different ways to consider the equivalence of fractions. Certainly not the only ways, just 2 simple ways that come to mind. If you have any questions about this or any other GED math concept, be sure to drop it in the comments. I will do my very best to answer it.